Okay, new lecture talking about minimum and maximum applications. So everything you've been learning about taking the derivatives, finding minimums and maximums, verifying their minimums and maximums are going to be put into practice in this particular lecture, okay? So let's get looking at that first problem again. I know you already read it once, but we're going to go through it one more time. Rags Limited, a clothing firm, determines that in order to sell X number of suits, the price per suit must be this equation. It also determines that the total cost of producing X suits is given by this particular function. So I've written down the equation and the function. I've represented what our variables stand for. That's always a great idea to do that, because if you don't, we kind of get up a creek. Okay, now they've given me 5 parts, and I really don't care about all 5 of those parts yet. All I really care about is part A, because I can't get to B, C, and all those other guys until I get A done. So let's see. A wants to know the total revenue. All right, so the revenue, remember, revenue is found by taking the price of an item and multiplying it by the number of items sold. Right? Okay, so in this particular case, what represents our price? Good, the 160 minus 0.05x. And what represents the number of items sold? Yeah, x, which is why it's a good idea to always write your variables down, right? So now this becomes r of x. It becomes a function with respect to x. And I'm going to go ahead and distribute this out. And I am also going to write it in descending order. Why? Because I've been taught very well that you always write your polynomials in descending order. I'm sure you have been taught that also. So there's our revenue function. Cool? Okay, good enough. And now they want to find the profit. All right, so question. All you business majors out there, how do you find profit? Say that again? Yeah, you take how much you made, which in this case is known as the revenue, and then what do? Good, you minus your cost, right? So all the money you've taken in, you pay out all your expenses, and whatever's left over is your profit. Agreed? Okay, so here's the thing. We've got the revenue function we just found. So that's the negative 0.05x squared plus 160x. And now the cost, do we have it? Yeah, C of x is the cost. So it's this particular function here. So we have 2,500 plus the 0.075x squared. Okay, so after you distribute this negative sign all the way through and collect your like terms, this is what I got. Hopefully the two of us got the same. I got that our profit function is negative 1.25x squared plus 160x minus 2,500. So distributing the minus sign, collecting like terms, that's nothing but algebra, which I'm assuming you guys are very good with your algebra skills. Cool? Okay, let's see what part C is. Part C wants to know how many suits must the company produce and sell in order to maximize the profit. Well, they want to maximize profit. So here's the thing. You know, they may not have said it, but we need to remember, when they say maximize, what are we looking for? Yeah, we are looking for a critical value. And how do you find a critical value? Good, you've got to take the first derivative, right? And then what do you do after you take the first derivative? Set it equal to 0. Awesome. So hang in there a second. Let's get first things first. We're maximizing the what? The profit. Okay, so I'm just writing that down so we know what we're focusing on. So we need to take the derivative, right? The first derivative of the profit function we just found. So go ahead, Pause the video, go ahead, take the first derivative, and then come back when you got it. Got it? Okay, so this is what I got when I took the first derivative. Negative 2.5x plus 160. And then you've got to do what? Right, to find the critical value, you've got to take that, set it equal to 0. And after you set it equal to 0 and solve for x, again, this is all your algebra skills, so I'm assuming your algebra skills are good. I got 64. Did you? Awesome. Now, here's the thing. We need to verify. You know, they don't say it, but my recommendation is we verify that that actually is the maximum. And remember how you can do your verification. You can do the first derivative test or the second derivative test. I choose to do the second derivative test. Why? It's quicker. So we're going to verify that a max occurs at x equaling 64. So we have to take the second derivative, which we get what? Yeah, we get negative 2.5. And even if we take this 64 and plug it in for x, we still get negative 2.5, don't we? Yeah, that's not going to change. It's a constant. And that's less than 0, so it's a negative number. Remember what the second derivative, remember what the second derivative tells you. It talks about, second derivative always deals with what? Concavity. Good. So since this is less than 0, this thing concaves which direction? It concaves down, which means right here at the top, you've got a maximum. So yes, there is a maximum that's going to occur at x being equal to 64. Cool? Yay! So what's next? D wants to know the maximum profit. All right. So how do you think you're going to find the maximum profit? Say that again? Yeah, I need to plug it in. What do I need to plug in? Good, I need to plug the 64 in. Now remember, x represents the number of suits. So I've got 64 suits and I need to find the max profit. So where are you going to plug the 64 into? Good, the profit function. With me? I'm plugging it into the profit function. Not the first derivative, because the first derivative gives me the critical value. Not the second derivative, because that tells me concavity. I want the actual profit, so we've got to plug it into the profit function over here. So we're going to use that function, and we are going to find P of 64. Cool? Okay, take a few moments, go plug it in, go find it, pause the video if you need to, and then come on back when you got it. Got it? All right, hopefully we agree. I got the maximum profit was $4,870. And that's going to be occurring at 64 suits that are made and produced and sold. Yes? Okay. There's one more part. Part E wants to know what the actual price is. Well, E wants to know the price. So how are you going to find the price? Good. They gave me an equation up here to find the price. They said the price is equal to, right, because that's what P stands for, the little p I should say, the price is equal to 160 minus 0.5 x. But since x is equal to 64, we're going to plug it in there, aren't we? So when we plug it in, what did you get? Good. I got the same thing. Your price is equal to $128. That's what they should charge in order to maximize their profit. That's what they should charge to sell the 64 suits and come up with $4,870 based upon this information right here. Cool? Awesome. Stay tuned. Okay, did you get a chance to look at that next problem? Let's look at it again. Find the maximum profit and the number of units that must be produced and sold in order to yield the maximum profit. And then they tell us on the next line, assume that the revenue and the cost functions, right, of producing X units. So again, here are the two functions they've given us. Here's what our variables represent, right? Now they didn't give us any parts A, B, C, or they didn't give us any of that. What was their question? Yeah, their question was find the max profit. Okay, so let's get that written down in plain English. Find the maximum profit. All right, so what do you think we're going to have to do first to find the maximum profit? Yeah, it might be a good idea to actually have a profit function. I don't see a profit function, do you? All right, so based upon the last problem, how do you find profit? Yeah, to find my profit function, I am going to take the revenue, which is all the money that's come in, and I'm going to subtract the cost, all the money I got to pay out, right? And we're going to have leftover. We're just saying. At least we hope we have leftover. Okay, so here's our revenue. That's the revenue function, I should say. And we're going to subtract the cost function. All right. Now you all go do your algebra, distribute your minus sign, collect your like terms. But when I did all that, this is what I got for my profit function. I got negative 0.5x squared plus 36x minus 20. Did you? Lovely. Okay, so now help me out here. I found the profit function. They want me to maximize the profit. So what do I have to do to maximize the profit? What's kind of like first on my list after I actually have a profit function? Yeah, this word maximize implies that you've got to find the critical value. And please make note of that. When you're maximize or even minimize, that means find that critical value. And the only way to find it is by taking the first derivative. So we need to find the critical value. And we do that by taking the first derivative of the profit function because we're trying to maximize the profit. So pause the video and then come back when you've got your derivative, and hopefully the two of us agree. So let's see what we got. I got negative 1x squared. Whoops, not x squared. There we go, negative 1x. See what happens sometimes if you work too quick? This is why you need to do it with me. Make sure we get the same thing. Okay. And then what do we do? Because all we did was found the derivative. Yeah, set the derivative equal to 0 to find that critical value. And in this case, we get the critical value of 36. Correct? Good. All right. Now what? Yeah, let's check and see if this 36 is there's actually going to be a max value, right? If there's actually going to be a maximum at that 36. How do we do that? Right. So to check it, it's easy to take the second derivative, right? We get just negative 1. My x is equal to 36. That means I would take that and plug it in for x, wouldn't I? So regardless, when I plug 36 in for x, I'm still going to get negative 1, aren't I? Because it's a constant, right? So that's not going to change, is it? Okay, which means this is still less than 0. And second derivative tells you concavity. So since this is less than 0, it concaves down, which means, yep, we got a max there. So yay! This is all working out like it's supposed to. All right, so we've got the max, or we don't have the max. We found that the max is going to occur, right? The max occurs at x equaling 36, so 36 units, right? And let's see, they actually want us to find the maximum profit. So what are you going to have to do to find the max profit? Good. Just like we did before, right? To find the maximum profit, we have to plug it in. Here is our equation. We're going to have to plug in the 36 units into this equation. And when all is said and done, pause the video, see what you get, and then come back. Meanwhile, I have to pick up my paper. Okay, what'd you get? Yeah, I got the same. I have the maximum profit is going to be $628 for 36 units of whatever. Cool? Stay tuned. Got another one. Ready for the next one? Did you get a chance to read it? Okay, let's look at it again. An apple farm yields an average of 37 bushels of apples per tree when 25 trees are planted on an acre of ground. All right. Each time one more tree is planted per acre, the yield decreases by 1 bushel per tree as a result of crowding. Now, their question is, how many trees should be planted on an acre in order to get the highest yield? So here's the deal. Right now they gave us a starting point. They said for the 25 trees, it's 37 bushels per tree, right? For 25 trees on this acre, they yield 37 bushels of apples per tree. And they said every time they add another tree, the number of bushels decreases by 1. Correct? Okay, so before we get anywhere, so if they add 2, then it decreases by 2. Add 3, decreases by 3, right? So here's the deal. This one's kind of got a 1-to-1 ratio going on, right? So don't write anything, just bear with me a moment. I'm going to let X represent the amount of, let's see, how do I want to state this? I want to let it represent the amount of increase. Which means my number of trees is going to be equal to 25 plus 1, because it's for every tree, right? 1 times the amount of increase. Again, this is a 1-to-1 ratio, but sometimes it's not a 1-to-1 ratio, so I need you to just kind of bear with me here a second. Which means the number of trees we have is going to be 25 plus 1x. Now, the number of bushels, on the other hand, is going to be 37 minus 1 times the amount of increase. And in this particular case, the number of bushels will end up being 37 minus 1x. X is the amount of increase. I'm taking how much I'm increasing by, multiplying it by this 1 to get the number of trees, but then I multiply it by this negative 1 to get the number of bushels. With me? Okay. So let's see. Their question is, how many trees should be planted on the acre to get the highest yield? All right, so highest yield. Give me another word for highest. Yeah, maximum. So they're being quite sneaky here. They want the highest yield, which means they want the maximum yield, right? Okay, so to find out the yield on this acre of land, what are we going to have to do? Yeah, we need to know how many trees are on this land, and then we need to multiply by how many bushels we get off each tree, right? All right, well, the number of trees that's planted on this land is generically represented by 25 plus x, right? You're okay if I drop the 1? Okay. And then the number of bushels per tree is generically written as 37 minus x, right? So this is the amount of yield that we are going to get. Now, we're going to distribute this out. Why? Because I just want a simple, well, it's going to be a second degree equation, but I want to multiply this all out. And, okay, some of you need to see me multiply this out, but I got 925 minus 25x plus 37x minus x squared. So my yield function, written in descending order, is this. Did you get the same thing? Good. Now, remember, what did they say? Yeah, they said maximize. So since they said maximize, we need to find the critical value. There we go again. So, max implies critical value, which means take the first derivative of the yield, because I'm maximizing the yield. Right? Okay. So when we take the first derivative, this is what I get. Hopefully you get the same thing. But to find the critical, you set it equal to 0. And after you solve, you get x equals 6, right? Good, I got the same thing. So that would mean that the amount of increase is 6. 6 represents the amount of increase. Now, we're assuming it's the max. How do we verify it's the max? Second derivative test. That's the easiest way to do it. So verify that 6 is where the max occurs. All right, so how do you do it? Second derivative. So I'm going to take the second derivative of my yield function, which would just give me a negative 2. Technically, I'm supposed to take that 6 and plug it in. And when I do, since this is a constant, I'm still going to get negative 2, right? All right, and since it's less than 0, concave down, which means since it concaves down, we have a max. So yay, we found that. Good? All right, now, the question is, in order to get the highest yield, how many trees should be planted on an acre? Well, let's go back to our tree function, or our tree equation. So, we got that the number of trees was represented by this equation. The number of trees was equal to 25, which was their base, plus 1 times the amount of increase. So in this case, they should plant 31 trees on the acre in order to get the maximum amount of yield. And if they wanted the yield per bushel, or pardon me, the number of bushels per tree, we could find that too, couldn't we? We would take 37 minus 1 times the amount of increase. So in this case, it would decrease the number of bushels per tree. But that's okay, they're trying to find the maximum. Got it? Okay, cool. Stay tuned. Got another. Okay, we're looking at a car rental agency, and it states that this car rental agency rents 444 cars per day at $40 per day. And it says for each dollar increase in rate, 10 fewer cars are actually rented. And they're asking us at what rate should the cars be rented to produce the maximum income. And then they actually want to know the maximum income. Okay, sound a little familiar? Yeah, it kind of sounds like that apple tree farm we just spoke about, right? Yeah, so let's check this out a second. Number of cars rented, oh, and that should be the daily cars rented because that's what they said per day, right? So daily. So the daily number of cars rented is 440 and the daily rate is $40. And now they're telling us, let's see, for each dollar increased in rate, they rent 10 fewer cars, right? So, kind of sounds familiar, except in this case it's not a 1-to-1 ratio like the apple tree farm was, is it? So here's the thing. I'm going to give us an X, and that's going to represent the amount of increase. Which means, let's talk about the daily number of cars. So the daily number of cars is 440, right? And we're going to subtract 10 for each increase. So it increases by 1, we minus 10. But if it increases by 2, we minus 20, don't we? That's why it's a multiplication problem. Which means our daily number of cars is going to be 440 minus 10 times X, which is that increase that they're talking about. Cool? Okay. And the daily rate is going to be 40 plus 1 times whatever the increase is. Correct? Now, when you multiply by 1, it doesn't change things a lot, and I get it. But just to make certain we keep consistency, we understand that there's a 1 should be there because it's for every increase we're multiplying by 1, just for consistency's sake. Okay, so far so good? Loving it. Now, before we get too much further in terms of the amount of increase, I have a concern right here. The daily number of cars, right, can't be a negative number, can it? That was the same with those bushels. They couldn't be a negative number, right? So I approach the bushels a little bit differently, but I need to make certain here that I'm going to approach it another way. So the other way I'm going to approach this problem versus the bushel problem is like this. I need to make certain that the daily number of cars, which is found by this equation, is greater than or equal to 0. And when I do this, it shows me that X has to be less than or equal to 44. Which kind of starts giving me a domain to work with. X has to be less than or equal to 44, but at the same time, you can't have a negative amount of increase, can you? So this is basically the domain I'm going to be working with. So I'm just going to kind of keep that in the back of my mind a second. All right? All right. So they want to know the maximum income. Well, they said max again, didn't they? Yeah, you know where we're going with that, right? Okay, but first, to find the income. What do we do to find the income? Good, we take the daily rate and we multiply it by the daily amount of rented cars, right? Daily number of rented cars. Okay, which means in this case our daily rate is given by this particular equation, and the daily number of rented cars. And so that's going to be our income based upon the amount of increase. All right, so multiplying it all out, and I'll do my multiplication for you guys. Make sure we're all good. Hopefully you're getting the same thing I am. Hopefully your algebra skills are honed. And if they're not, well, you might want to get some practice on distributing binomials. Okay, there's my income function. Did you get the same thing? Yay! We're matching. Okay, so now what? Now I need to maximize. How do I do it? Critical value. How do I do it? First derivative. So my first derivative of the income, what are you guys getting? Good. Negative 20x plus 40. Great. Then what? Set it, that's a funny looking tick mark, isn't it? Set it equal to 0. I'm with you. What'd you get when you solved? X equals 2. Great. And that falls within this domain, doesn't it? Lovely. Okay, now, since this is within this domain and I have endpoints, right? We are actually finding an absolute maximum. With me? Because I actually have this domain to work with, and gratefully what I found is in the middle there, we are actually looking at the absolute maximum. So, let me get my pen. We're actually finding absolute max. And I've got x equaling 0, x equaling 2, and x equaling 44. Which means the income at 0, here's my income equation, right? What do you get at the income at 0? 17,600. Okay. At x equals 2, what's your income with the increase being 2? Go ahead, work it out. I've already got mine worked out. You guys need to work yours out. What'd you get? Good. 17,640. And the income at 44, at the amount of increase being 44 is? Yeah, 0. I got the same thing. I got 0. Okay, so what does this mean then? This means, here's the largest increase, right? Or I should say the largest income, which means I should increase by 2 at the most. With me? I should increase by 2 at the most in order to maximize my income. So that means your daily rate is 40 plus 1x. What do you get? Good. Your daily rate should be $42, right? They didn't ask for it, but what's the amount of cars rented? And it's daily again. The daily amount of cars rented would be 440 minus 10 times the amount of increase, which is 2, right? So 420 cars will be rented daily, and the maximum income would be $17,640. Cool? With me?